For today's video on PM Customs, I'm going to be doing some welding work for Aaron over at DCT Teacher 1. This is a CertiWeld welding table, which is very much like the one I'm standing in front of, but it is a very small sort of benchtop version. Aaron plans on using this as his welding table and is going to store his fab gear MIG welder underneath it. Checking the instructions, the parts list here, it turns out we've got one 104 plate where we should have two, and we've been given a 105 which isn't even on the list. Everything else checks out, but when I compare these two plates, which are supposed to be identical, this slot here is opposite hand, and the little notches that the corner plates lock into are in the wrong position. What we've decided to do is to fill these slots up with weld and then cut the slots from the opposite side, and we're just going to open up the little notches, the little notch cutouts to match the proper plate. Okay, so this is all welded together now, and all the welds are being ground flat using a flat grinding technique so that we don't dish the metal, because this needs to be referenced flat. We had a little bit of a drama with this cross member here, this stiffening plate. This part number is 105, which I believe is for a different model table because it's not in the documentation for this one. It was a very close match to 104, which there was supposed to be two of, and we only had one. However, the slot was cut from the opposite side. So what we did as a workaround is we cut the slot all the way through, and this part now is in three different parts. We could get away with that in this instance because we have this welding table to work with. So we've got a nice flat reference table. If we didn't have that, then this probably would have caused some problems because these stiffeners are what are expected to keep the table flat after you tack it together. By cutting that into 3 pieces, we've ended up with one backbone essentially broken in 2 pieces, in 2 places, which didn't matter too much for us, like I said, because we had to clamp down to this perfectly flat table. So we got around it. So all I did once it was assembled is I welded the fillet welds to the longitudinal members. That essentially put the strength back into it, and there's about 2 inches of weld on both sides, so there's heaps. These corner blocks, the stiffeners and the table are all tacked together and block tacked, so just small stitch welds in each corner, just to lock it all together before final welding. Final welding, there is instructions on the internet, however we have a nice flat welding table, so we just did it as per industry standard, and that is typically to back step and centre out. So you start in the centre and you work your way outwards, and your direction of welding should always be towards the weld you've just finished. That way the weld you've just finished is adding integrity and fighting the distortion. The other thing I did was to stagger my welding. I didn't just weld all in one section. I moved around the table to keep the temperature down, and that also helps keep it nice and flat. These welds on the face and on the corners are what's called a slot weld, and the idea is that you want to focus your weld, whether you're stick welding, MIG welding or TIG welding is irrelevant. You want to focus your arc right down the centre, and you want to let it fill up from the bottom. You don't want the arc hitting the top edge and then sinking down. You'll end up with lack of fusion on the tongue at the bottom, or the edge of, you're essentially welding the edge of this plate to the face of this plate. So you want to have a nice hot arc. You don't want a dip transfer, you want a spray transfer if you're MIG welding. And you want to have that weld essentially melting the edge underneath and then filling up and catching the edges of the flat plate so that you get good fusion. And then at the end, simply flat grind. Use a flat grind technique with a flappy disc so you don't eat into the material. Over here, this is the leg system that they supply all laser cut, so all these parts click together like a Meccano set. These plates here, we bolted down to the bottom of the welding table, stood the legs up, put the cross members in, and then tacked it all together assembled. That gives these plates a nice flat reference point using the base of this. These are laser cut and located into the legs, so they're fine. And then what we did is we took it apart, flipped it over, and we sat the base plates down on the welding table, clamped them down, and then tacked them into position on the table so that they're nice and flat too, so that there's no rocking or rolling once it's all assembled. And this is not part of the standard design, but this is an easy enhancement that anyone can do. We just cut a bit of 3mm plate, or 1/8 for the American viewers. And this plate is just cut to fit inside, got the corners cut off to clear the fillet welds. And we're just using magnets or helping hands, there's a whole bunch of names for these, to get it nice and flush with the top. I'll tack it in, and this is where Aaron's going to sit his little multi-process welding machine, so that you can wheel the whole thing around as a sort of portable workstation. So I'll get to it.
Okay guys, that concludes today's video. We've got it all wiped out, all cleaned up, and it's in the boot of my car to take home. Weighs quite a bit, so I'll struggle getting it out of the boot. Just want to say a really big thank you to Peter for coming in today and sharing his experience, you know, as a ticketed welder. And as you know, Peter's one of my engineering instructors here at the college as well, where he teaches the students to a Certificate 2 level in their high school years. So big thanks to Pete from PM Customs. Thanks, Pete. Really appreciate your work today, mate. Thank you very much. And closing line today, guys, keep it arcing and keep it sparking. Good on you. See you next time. Cheers.